Imagine stepping outside late at night and feeling that something is wrong before you even look up. The air is calm, the streetlights hum softly, but the moon feels different. Not brighter in a poetic way, heavier, closer, hanging lower in the sky than it ever should. Hour by hour it grows larger, dragging invisible forces across the planet beneath your feet. Long before any collision, Earth would already be unraveling. The oceans would respond first. Tides would stretch higher than anything recorded in human history, flooding coastlines, swallowing ports, and erasing entire cities that once felt permanent. Water would surge inland, reshaping continents while millions struggled to escape. Satellites orbiting above would begin to drift, their paths warped by the moon's growing gravitational pull. GPS would fail. Communication networks would collapse. Weather forecasting would become impossible. And beneath the surface, the planet itself would revolt. Earthquakes would ripple across continents every single day. Volcanoes would awaken in violent chains, choking the sky with ash. And then, just before impact, something unexpected would happen. The moon wouldn't crash into Earth at all. It would be torn apart. Earth's gravity would shred it into countless fragments, scattering them into orbit and forming a glowing ring system around our planet. A ringed Earth. Beautiful. Alien. For the few survivors left behind, the night sky would be filled with luminous arcs and constant meteor showers, moon dust burning as it rained through the atmosphere. It would be the most breathtaking sky humanity ever witnessed, arriving at the worst possible moment. Now pull back from destruction and think about distance. In 1977, humanity launched two machines with a mission unlike anything before them. Voyager 1 and Voyager 2 weren't just probes, they were messengers. Designed to take advantage of a rare planetary alignment that won't happen again for another 175 years, they used gravity itself as fuel, slingshotting from world to world. They revealed Jupiter's raging storms, Saturn's intricate rings, Uranus's tilted rotation, and Neptune's supersonic winds. These weren't just photographs, they were first encounters. And then, the Voyagers kept going. Today, Voyager 1 is farther from Earth than any human-made object in history, so distant that sunlight barely touches it. And knowing this, NASA made a deeply human choice. They attached a message, not instructions, not warnings, a memory, the golden record, sounds of nature, music from across cultures and centuries, greetings spoken in dozens of languages, images chosen to explain who we were, how we lived, and what we valued. A time capsule drifting endlessly through interstellar space. One day, long after Earth's cities crumble and oceans reclaim the land, that record may be the last proof that humanity ever existed at all. Before moving on, pause for a moment, because the next image is real and unsettling. In 1984, astronaut Bruce McCandless stepped away from the space shuttle without a tether. No cable, no lifeline, just him, a jetpack, and the void. Floating freely more than 100 meters from safety, he became the most isolated human in history. From Earth, the photograph looks calm, peaceful even. But inside the helmet, there was only silence, no wind, no sound. When McCandless later described the experience, it wasn't fear of drifting away that haunted him most. It was the cold. The instant he left the shuttle's shadow, space began draining heat from his body. Imagine floating there, knowing one wrong movement could send you drifting forever, becoming nothing more than another silent object orbiting the planet. Far beyond human vulnerability, the universe itself can tremble. When black holes collide, they don't merge quietly. They shake reality. These cosmic events send gravitational waves rippling through space-time itself, stretching and squeezing the universe like the surface of a disturbed lake. Einstein predicted their existence over a century ago, but it wasn't until 2015 that humanity finally detected one. Scientists used an instrument called LIGO, where laser beams travel down 4-kilometer-long tunnels and bounce between mirrors. When a gravitational wave passes through Earth, the distance between those mirrors changes by less than the width of a proton, and yet we detected it. For the first time, humanity didn't just observe the universe, we felt it move. On Mars, endurance quietly became legend. The Opportunity rover was designed to last just 90 days. It survived for 14 years, powered only by sunlight, Opportunity crawled across the Martian surface, traveling more than 28 miles and sending back images that changed how we see the red planet. It watched seasons change. It studied ancient rocks that once interacted with water. Then came the storm. Dust filled the sky, blocking the sun. Power faded. Opportunity sent one final message home. My battery is low and it's getting dark. After that, silence. Engineers listened for months, hoping for a reply. She never answered. A machine, yes, but one that carried human hope millions of miles from home. Quick pause here. If you're still with me, this is Astrion. Our goal is to reach 5,000 subscribers, and this video has a challenge. Let's hit 250 likes and 250 comments. If you've made it this far, drop a comment and tell us which moment stayed with you. Subscribe to Astrion and become part of this journey as we continue exploring the universe's quiet, unbelievable truths. Back to the sky. On Earth, sunsets burn red and orange. On Mars, they turn blue. Fine dust particles in the Martian atmosphere scatter light differently, allowing blue wavelengths to dominate as the sun dips below the horizon. The sun itself appears smaller, distant, almost fragile. Mars constantly reminds us that even familiar things behave differently when viewed from another world. And speaking of change, one of the brightest stars in our night sky is nearing the end of its life. Betelgeuse, a red supergiant in the constellation Orion, behaves strangely. It dims, it brightens, it ejects massive chunks of its surface into space. Recent research suggests it may already be fusing carbon in its core, a sign that its final moments could be approaching. When it explodes, it won't be subtle. It will shine brighter than the moon, visible even during the day. It will cast shadows at night. While it's far enough away to leave Earth unharmed, Betelgeuse reminds us of a simple truth. Even stars are temporary. Black holes take that truth even further. Our galaxy alone may contain over 100 million black holes, most invisible, silent, and undetectable. At the centers of galaxies, supermassive black holes consume staggering amounts of matter, surrounded by glowing disks of gas and light. For decades, they existed only in theory. Then we photographed them. By linking telescopes across the globe, scientists created a virtual Earth-sized telescope. And it worked. Sagittarius A star, the black hole at the center of our own galaxy, sits 26,000 light-years away. M87's black hole lies 53 million light-years distant. What we captured weren't animations or artist impressions. They were real images, shadows where light itself disappears. In 1990, as Voyager 1 prepared to leave the solar system, Carl Sagan made a quiet request: turn the camera around. From nearly 4 billion miles away, Voyager captured a tiny dot suspended in a beam of sunlight, Earth. In that image lies every war, every love story, every civilization, every human who has ever lived. Just a pale speck in a vast cosmic ocean. Not all space stories inspire awe. Some carry tragedy. In 1957, the Soviet Union launched Laika, a stray dog, into orbit. She had no chance of return. Scientists knew it. She didn't. Sensors recorded her heart rate tripling during launch. The capsule overheated. After hours alone in space, her heart stopped. Laika became the first Earthborn creature to orbit our planet, and a reminder of the cost of progress. Even time itself isn't fixed. The moon is slowly drifting away from Earth, about 1.5 inches every year. As it does, Earth's rotation slows. Billions of years ago, a day lasted only 18 hours. In the distant future, a single day could stretch to nearly 28 hours. Time, like everything else, is constantly changing. Far beyond our galaxy lies Phoenix star, the largest black hole ever discovered. Its mass is so immense that its event horizon spans distances larger than some entire galaxies. Traveling at the speed of light, it would take more than 70 days just to orbit it once, and it's still growing. And beneath all of this lies a quiet truth. The oxygen you breathe was forged in dying stars. The water in your body traces back to the birth of the universe. The atoms in your hands were once part of something ancient and burning. Astronomy is the universe learning to look at itself. And you are not separate from it. You are made of the same material as stars. If this journey made you pause, even briefly, subscribe to Astrion. Help us reach 5,000 explorers, hit the 250 like and 250 comment challenge, and become part of this growing community. The universe isn't finished revealing itself, and neither are we.